James Davis and then Graham String.
Thank you, Chair. I'm interested in the access that amateur astronomers have to facilities in your country, such as observatories, planetaria and radio astronomy facilities. Perhaps if we could start with Professor Kramer in relation to Germany. Thank you.
Sure. Yeah, I think that's something Germany can actually be very proud of. We have about 40 or 50 planetaria across Germany, which can host more than 50 people. We have 10 which can host more than 300 people. They get hundreds and thousands of visitors. And we have this small popular observatories, which are mostly done by amateur astronomers, where you can actually get to the telescope and observe. These are usually small telescopes, but not all of them. So some of them are sizable. When Germany is not the best country to observe the optical sky sometimes, just like Manchester. But the people are really drawn to this. Last year we actually had something funded by the ministry. We had built a movable planetarium. We went to the pedestrian zones in the cities in Germany and really also wanted to drag people into the planetarium that usually wouldn't go there. So that was a huge success. We had 60,000 people just on that particular tour across Germany. We also do teacher training, so we make sure that there's an organized teacher training across the country where we invite teachers from high school to tell them how to report also research results to the school children and so on. Yes. What we haven't done very well is, I think, to bring the public to participate in real optical and radio astronomical research. Radio astronomy is, you can do only so many things with a telescope. It also doesn't have to quite appeal to the public because you only see some data stream coming out. You can't see it with your own eyes. There's nothing better than actually looking through a telescope and see the stars or Jupiter or Saturn with your own eyes. But in principle, this is something that is very well developed in Germany. Just this morning, I got an invitation to participate in a teacher training again. And we also have the House of Astronomy in Heidelberg, which organizes teacher training in Germany. They're also hosting the IAU, the International Astronomical Union Office of Education. So this is something taken very serious in Germany. And I think that is something we can really be proud of.
Mm-hmm. Yeah, so you've touched there, obviously, on the public outreach that takes place in Germany. And do you have any comment on the particular methods that work in engaging the public and school children? I know you've talked about some of those in place, but how can those efforts best work?
I think you will be amazed if you give a talk at school, even at primary schools. The questions that you receive from these children are amazing. They are really amazing. They want to know about black holes. They want to know about stars. And they're very intelligent questions, sometimes so intelligent that you have to think about the answer for a while. So exposing these kids at this very young age to astronomy is really a draw into STEM fields later on. We see this all the time. So I think engage them with nice pictures, maybe planetarium, trying to show them aliens is always a favorite topic, of course. Trying to teach them about the fascination of the universe. And someone said the most attractive things are dinosaurs and space. And I think that is actually true. Yeah. And so by getting these school children very early, I think we can draw them into STEM research, and they may not become astronomers, but they will certainly be interested in natural sciences and engineering and so on. So I think there's almost nothing that wouldn't work if you try to excite them, because they're really, really fascinated by this subject.
Very good. Dr. Dempsey, Netherlands, what is the state of play with access to facilities for amateur astronomers, and how developed are the relationships between professional and amateur astronomers?
Oh, it's very comprehensive. I think I would second Michael on one thing, which is I can't. There's not many places worse for optical astronomy than the Netherlands, and so we're quite limited in terms of the size of the optical facilities, and with the radio facilities, one of the examples is directly outside of my office window, the Dwingelo telescope, which was first built in the 1950s. And hasn't really been scientifically competitive since the 1990s, however, was taken over by a group of retired Astron employees, and they renovated it. They found the funding and they renovated it. It is now a public access facility that they allow any amateur and student astronomers to use. The renovation makes it look, I think, better than it was when it was originally done. It is nearly operating every single day. They're incredibly invested. And in the summer, which we're just going into, they have thousands of visitors that come and do this, and they track CubeSat satellites. They tracked the Artemis mission, when it went to the moon. So it's an incredibly active group. And I think this really is what you see with these amateur groups, which when they're engaged and supported by the professional astronomy of either a region or a nation, they just are self-propelling. And so if you can give them that support, and it doesn't need to be necessarily very large monetarily, they really do enable an entire other engagement set than most professional astronomers have either time for or potentially interest in.
Yes. And how do you feel public outreach is working in the Netherlands in general? And again, what kind of methods do you think work best?
I think it's an incredibly diverse and high level of engagement. And I'm very impressed here in the Netherlands with the diversity of the types of engagement. An example is in Nijmegen, they've just done this very heavy indigenous art exhibit focusing on black holes. And so it's a combination of artists, it's a combination of written work and the Event Horizon Telescope discovery space. So they're very creative, and this, like Michael mentioned, makes it accessible to people who wouldn't have otherwise maybe just turned up for an astronomy talk. So having these kinds of collaborations with artists, with writers, I've seen a lot of very successful ones, really does broaden the engagement set from the typical that you might say just from general outreach talks, which, while I think are vital, I think they shouldn't be the whole suite of ways we engage. Some of the other interesting ones are, I learned this in Hawaii, is community engagement doesn't necessarily mean scientists talking at the community about astronomy, but just being a better community member, and therefore you just get to be part of that community. We also did open up the telescopes on Mauna Kea for high school students to actually ask for observing time. And this was an incredibly successful program. And Michael already mentioned that, kids end up, really surpassing your expectations. We thought they were going to come up with some very basic requests. Some of these programs that got awarded some time were so ambitious, we couldn't do them with the best telescopes in the world. And some of them, these high school students, even published scientific research papers with their graduate students in the universities. So it was really, really impressive a way to engage. And some of those students, and Michael mentioned as well, ended up being not just going directly into astronomy, but staying in STEM where perhaps they wouldn't have otherwise because they had such an authentic early experience.
Right. Thank you very much for that comprehensive reply.
Thank you very much, James.
Perhaps if I switch to Professor Thomas just while we figure out whether there's a solution.
Yes.
Simply to ask that where there are national launch capabilities, what advantages does that give to astronomers?
I got the question.
Mr. Cremonesi, we can't hear you. We can see your lips moving, but that's it. So I think that if I direct that question, Professor Thomas takes that question, and then we might try the telephone or something like that, perhaps. But James said to Professor Thomas.
Yeah, national launch capabilities.
Yes.
There's Switzerland, of course, is a relatively small country. It's 1/8 of the size of the UK population-wise. our spending on space is probably about a third or a quarter of what the UK spends, something of this sort. And so, there's no national launch program. There were some startup companies that there was a startup company called S3, which started up in around about 2014, I believe, but this went bankrupt relatively quickly in 2018. So it's not something at the moment that we think is really viable at a national level for Switzerland. In general as well, if you want to get into that market, it is very competitive now, and so it's going to. In order to get into that market, it requires quite significant investment,
yes,
and a large amount of customers for that activity, and you have to guarantee that. So checking the market is very important.
So it's difficult to deliver particularly in smaller countries, but it does give big advantages to astronomers. I presume you would agree, where it is possible.
Yes, and yes. Of course. I mean, we've also tried rather hard to look at ways in which Switzerland can expand its palette of things towards the higher end. So building spacecraft and so on. We've looked at that and done some activities in that area. But if you're able to launch your own spacecraft, yes, this has advantages particularly for looking at some of these niche areas that Professor Kramer was talking about a little bit earlier.
Yes.
We found one of these things in one of these niches with a program called KEOPS, which was a joint program between Switzerland and the European Space Agency. It's a low-cost mission. It was a 50 million from Switzerland, approximately 50 million from the European Space Agency, and it was following up transits of planets across the faces of stars and monitoring this, and it's done a great deal of work for relatively cheap in a niche area. And but there we're not launching it. We're just simply there having bilateral agreements with people that can launch for us.
Okay.
Let's try bringing in Mr. Cremonesi. See, now you've got your headphones on, whether that's making a difference. Could you say something to us?
Yes.
That's better.
Can you hear me better now?
We can, yes, absolutely. James, do you want to give your question to Mr. Cremonesi?
I think if we go back to the original question, if that's okay, which was how well joined up is the Italian space and astronomy sector in terms of research, technology and government support?
So in Italy, I think that most of the space activities are directly funded by the National Space Agency, ASI. And then there is research and development in the research institute and the universities. But if you like to be involved in large projects realizing big instruments aboard the space mission, for sure we have to work with the ASI, with the National Space Agency, in order to get funding. And I think that it's very important, such a point, to have a stronger collaboration between the university and the research institute, because I'm an employer of the research institute where I don't have the duty to teach, and instead of my colleagues at the university. This is important to collaborate with the university because, of course, for my projects, my long-term projects, I need students, PhD students, and only thanks to the collaboration with the university is it possible to get students and to get people to pay for postdoc later on. So in any case, the space agency can fund the realization, the operation related to the space instrument, but the research, the data analysis is more devoted to the research institute at the university. Even if sometimes the funding that we get for the large project for the space instrument are enough also to have a research, to make a research. to prepare the observation and to analyze the data that will be acquired by the instruments.
Okay, thank you. And from your understanding, what could the UK learn from the Italian approach?
So I think that one important point is, for instance, how the people can stay with us without having a permanent position. I mean, in Italy, we can pay for 6 years a postdoc, and then there is another kind of contract after the PhD that is the fixed term research without any limits. It means that I can pay for 10 years a people working on my project. This is very important because, for instance, I'm strongly involved in the Bepi Colombo mission, started 24 years ago, and will arrive to Mercury just in a couple of years. It means that if I had to change every 3 years the postdoc, it would be a nightmare to me, because every 3 years I have to hire new people, I have to educate, to teach to the people in order to have the right experience and competence that I need for the project. I think that the most important point is possibility to pay postdoc for longer times in order to have prepare people, in order to arrive to the target of the mission with the people that started with me at the beginning or just in the middle of the project.
Okay, thank you. And finally from me, if I can go back to the second question, which is about national launch capabilities and how useful they can be to astronomers. Your perspective on that, please.
So in Italy, we have a small launch capability, or we have to ask to other entities as European Space Agency. I think that could be important because there are large projects, large missions, but in such a case, if I needed to validate some technology, if I needed to validate the new kind of instrument, maybe I had to start with a small prototype. The small prototype means that needs a launch of small satellites as a CubeSat. CubeSat are very well acknowledged in this time because several people, several groups try to get funding to get instrument on board CubeSat that could be launched also by small launch capability, available also in Italy. And in such a case, I can, for instance, I'm a planetary scientist, I'm involved in a space mission to explore planets. But if I will be able to test, to realize a small prototype of the instrument, to fly it in the CubeSat around the Earth, I will be able to validate very well my instrument that could be ready for other deep space missions.
Thank you very much.
Thank you very much, James.